Find the number of ways 66 identical coins can be separated into 3 non-empty piles so that there are fewer coins in the first pile than in the second pile, and fewer coins in the second pile than in the third pile. Right, so we are basically counting. If we think of the number of coins as grid points in a three-dimensional lattice. So along the x direction is the number of coins in the first pile, along the y direction is the number of coins in the second pile, and in the z direction is the number of coins in the third pile. Then we have the sum of the three numbers is equal to 66, and that slices a plane. That slices a plane through this cube of lattice points, and we want to count not only how many points are on that plane, but we need to eliminate the ones where one coordinate is less than the other. That's my first instinct when thinking about this. But maybe there's another way. So what I can do is imagine the number of coins. So which pile has the most? The third pile has the most number of coins. I'll draw it like this. We have some number of coins there, a bigger number of coins there, and a much bigger number of coins there. So for the large pile, 66 in total, it'll be pretty easy to figure out the largest possible number and the smallest possible number that can go there. The largest possible number that can go there is 63, because then we have 2 and a 1. And the smallest number that can go there, well, this is not allowed. So we have to, pass one coin up. So if we have 23, 22, and 21, that's allowed. So the smallest number that we can put here is 23, and the largest number is 63. I think this is probably a better approach, what I'm about to do here, rather than taking the lattice points and taking a slice through the cube of lattice points and all that. Okay, this is the arrangement with the most number of coins in the third pile. This is the arrangement with the fewest number of allowable coins in the third pile. Wait. Yeah, the fewest. Right? If I have 22 coins here, then I need at least 22 in one of those piles, which is not allowed. Okay, so what I'm going to do is suppose I have n coins in the third pile, and figure out how many ways I can, as a function of n, how many ways can I distribute the remaining coins here. And then I'm just going to take that as a function of n and add it up for n is equal to 23 and 63. So n is the number of coins in pile 3, and f of n is number of ways to distribute coins in piles 1, and 2, based off of there being n in pile 3. Okay, so let's try to figure out f of n. So then the answer we want is going to be the sum as n goes from 23 to 63 of f of n. And I suspect this function is going to be linear in n, almost certainly. It might not be, it might depend on whether n is even or odd. The exact expression we get might depend on whether n is even or odd, but that's okay. I think it'll still be more or less linear in n, and it'll be an expression that we can compute this sum of. Okay, so I have 2 piles, and then now the number of coins is 66 minus n. Okay, so how many ways can I do this? Well, I'm going to think in a similar way. Now I have to break it up whether n is even or odd. Suppose n is even. Then the largest number, the largest number I can put there is 66. Is this, let's call this m. Okay, so I have m coins to split between 2 piles. The smallest number I can put there is, it's going to be m over 2 plus 1. That's the smallest number. Because clearly, if m is even, m over 2 is an integer. I can put m over 2 here and m over 2 here, but that's actually not allowed. So I have to put m over 2 plus 1 and m over 2 minus 1. And the largest I can put there will be m. I could put all of them here and 0 there, but that's not allowed. So I can put m minus 1 in the first pile. Okay, so how many ways, how many numbers is that? So the number of numbers in this list, let's not mark it with an arrow, let's mark it with a ... Right, that's the smallest, that's the largest. The number of numbers here is m minus 1 minus m over 2 plus 1 plus 1. So that's equal to m over 2 minus 1, which is equal to 66 minus n over 2 minus 1. So this is f of n when n is even. (33 minus 1 is 32). 32 minus n over 2. Okay, now let's assume that it's odd. So same situation. So I have m coins to split between the piles. I can put m plus 1 over 2 in the first pile and m minus 1 over 2 in that pile. That's legal, and this is the smallest number I can put there. The largest I can put there is, again, m minus 1, and then we have 1 there. So this is smallest and largest. How many numbers is that in total? That's m minus 1 minus m plus 1 over 2 plus 1. Let's write this as m minus 1 minus m over 2 minus 1 over 2 plus 1. So this is m over 2 minus 1 over 2, m minus 1 over 2. And that's n minus, 66 minus n minus 1 divided by 2. So 65 minus n over 2. This is f of n when n is odd. Okay, let me write it down in general then. So f of n is equal to 66 minus n over 2, or 65 minus n over 2, n even, and n odd. Oh, not quite. This simplified, let's not write it this way, let's write it as 64 minus n over 2. Okay. So what do we have? We have a sum as n goes from 23 to 63 of f of n. This is a sum. K goes from I want to write it like this. So when k is equal to 11, k is equal to 11, I get 23. And when k is equal to 31, wait, is that right? What are the extremes again of the numbers 23 and 63? Yeah, okay, no, that's correct, okay. And here I want to pick out the even numbers. So the first even number, in this range is 24. So that's when k is equal to 12. The last even number is 62. That's when, again, k is equal to 31. So for odd, I have 65 minus 2k plus 1 over 2. For even, I have 64 minus 2k over 2. Are these the same expression now? 64 minus 2k over 2. Yeah, so now I can just let's just keep them separate because yeah, this is fine. Okay. This first one, so it's an arithmetic sequence or arithmetic series. How many terms are in this thing? 21. The first term is 64 minus 22. The last term is 64 minus 62 divided by 4. Right? Sorry, I forgot to divide by 2 when I was talking about that. And how many terms are here? There are 20. The first term is 64 minus 24 divided by 2. The last term is 64 minus 62 divided by 2. So let's divide that by 4. Okay. 21 times 64 minus 22, 42 plus 2 divided by 4. Plus 2 divided by 4. Okay. 21 times 11 plus 5 times 42. 21 times 11. $220 plus 11 plus 210. 231 plus 210, 441. I think that'll be my answer, right? I really don't want to have to go back now and check all of my arithmetic and so on. I think my approach here is probably I mean, it's not the first thing that came to mind, but it's the first thing that came to mind that seemed to be tractable and easy to approach. So we're basically conditioning on how many coins are in the third pile and figuring out how many ways we can then distribute between the remaining piles, and then adding up over the number of coins that are allowed to be in that third pile. So I think as long as I didn't make any counting or arithmetic mistakes in each of these individual steps, that would be the main source of an error here, I think. But you know, I'm confident in the logic that worked out here, so that'll be my answer, 441. If I find any mistakes, then I'll let you know. Thanks for watching.